Okay, now that we understand what normal distribution is, let's talk about SPC tools, which is statistical process control tools. There are four different tools that we will cover. The first one is the scatter diagram. And the second one is histogram. And the third one is the Pareto chart. And finally, we will cover the control charts. So what is the use of all these four tools? What are we going to use them for? Well, we use those four tools to visualize the process or visualize the distribution of the data sets. Scatter diagram will give us the relationship between two variables. It's the relationship between two variables. Histogram, it will tell us whether the data is normally distributed or not, or whether the data has a bell curve or not. Bell curve or not. Pareto chart, it identifies what items cause the most of the effects. Identifies what items cause the most of the effect. Cause the most of the effect. And finally, control charts will tell us whether the data has normal variation or special cause variation. Okay, so we'll start with the scatter diagram, but the common goal of those four tools is to put the data on a clear platform so that we can visualize the process. This is the common goal of those four tools that we will cover today. So let's talk about the scatter diagram. Scatter diagram shows the relationship between two variables. And we use scatter diagram to show whether the independent variable will change the dependent variable, or scatter diagram is used to tell will my dependent variable will change as a result of what independent variable is doing. Okay. All right, so what I mean by the dependent and the independent variable here, let's assume that we have the x-axis, and the x-axis is the independent variable display. So, or it displays the independent variable. And we have the y-axis, and the y-axis it displays the dependent variable. Okay, so the dependent variable here, let me use a different color. The dependent variable here will change as a result of what independent variable is doing. Okay, let's give an example. Let's say that we want to create a scatter diagram or a scatter plot for the following data set, and let's put the data set on the board. Let me just open another page. All right. the following table represents the hours of workout and the consumed energy or the calories. So let's assume that we have the data for the workouts, so hours of workout versus the calories. Okay. All right, so let's assume that we collected some data, and based on the data that we collected, after working out for 25 minutes, we consume 65 calories. Okay. After spending 36 minutes, the amount of energy that we use or that we consume is 58. And let me fill the rest of it. So when we work out 45 minutes, it's 79 calorie. 48 minutes, it's 81 calorie. 30 minutes, it's 57 calorie. And 28 minutes, 64 calorie. And let's put one more, 71 minutes, and we consume 83 calorie. Okay, so we want to figure out which one is the dependent and which one is the independent variable. Okay, so one of these variables, either hours of workout or calories, will change as a result of what other variable is doing. Okay, as we can see here, we have the hours of workout and the calories. In this case, hours of workout is the independent variable, and the energy that you consume is the dependent variable. Because ideally, as you spend more time in the gym, the amount of calories or the amount of energy that you burn, that you consume, will increase, right? Well, that's our assumption. We don't know if that's going to increase or not. I guess it's depending on the activities that you do in the gym. But ideally, we expect it to increase, okay? So that means our dependent variable, calories, will change as a result of what independent variable, which is the hours of workout, is doing. Okay, so independent variable is the hours of workout, and the dependent variable is the calories. Okay, so let's put those data. On the Clear platform. So again, the y-axis is the dependent variable and x-axis is the independent variable. So this goes from 10, 20, 30, 40, 50, 60, 70, and 80. So this is the hours of workout, and our independent variable on the y-axis, this is 10, 20, 30, 40, 50, 60, 70, 80, and 90. Okay. All right. So let's plot the data. The first instance that we are looking at is the instance number 1. So we spent 25 minutes in the gym. That's the point for 25 because this is the line for the independent variable. And we burned 65 calories, okay? So 65 here, and the intersection between those 2 points is the red line. Okay, And the second instance that we have is we spent 36 minutes, which is approximately here, and we burn 58 calories. So 58 is going to be here, and the intercept between those 2 points is going to be here. And the third one is by spending 45 minutes, we are burning 79 calories. Okay. And the fourth point is by spanning 48 minutes, we burn 81 calories. And the fifth one, by spending 30 minutes, okay, and the amount of energy that we consume is 57, which is approximately here, right? All right, so again, I'm looking at the intersection between those 2 points, okay? When they intersect, that's the point that I want to mark. And when you spend 28 minutes, which is approximately here, you burn about 64 calories. So 28, it's approximately here, I guess, right? Okay. This was number 6. And number 7, when you spend 71 minutes, you burn 83 calories. Okay. All right. So this is the theory behind the scatter diagram. Okay. You find the points on the x and the y-axis. Again, x-axis represent your independent variable, and the y-axis represent your dependent variable, or displays your dependent variable. Then you find the intercept between those 2 points and plot it on the graph. Then it gives you the relationship between 2 variables. Okay, so this is a good visualization tool to tell whether the data is trending up or trending down, or you can tell how the data behaves, right? For instance, in another example, the scatter diagram, we can tell us the wine consumption in liters of alcohol from wine per person per year against that from the disease, right? Or scatter diagram can tell us the gas consumption versus how fast you're going. So there are different examples that we can give for the scatter diagram, and scatter diagram has different names: scatter diagram, scatter plot, scatter diagram plot. So in literature, it has different names, but scatter diagram, in short, makes it easy to spot trends and the correlations between 2 variables. Again, scatter diagram makes it easy to spot trends and correlations between 2 variables. And you can always find the inverse relationship between 2 variables on this platform. So if you find such a relationship, then you can use the linear regression to find curves of best fit. But this is not something that we're going to cover. We're not going to be covering linear regression in this class.